Okay, so if I type the things I'm saying, hopefully it'll be at a good enough pace so I'm not going too fast, okay? So recently this question came up in the 2022 AMC Junior, yeah? Okay. So I think it was question 27, yeah? So given the digits 1, 2, 3, 4 dots 8, yeah? We want to form two 4-digit numbers, yeah? Add them up and then calculate their digit sum, yeah? The question asks, what is the difference between the largest and smallest possible such values, right? Okay, so it's kind of a nice transition into AIMO because the question, like question 26 to 30 is kind of like AIMO questions 1 to 8. The same rules anyway, right? The only difference is you can get points even if you get it wrong. Whereas in AMC, obviously, it's all or nothing, yeah? Okay. Yes. So the rules are similar for this AMC question as for the AIMO, with the difference that you cannot get partial marks for the AMC, right? Okay. Okay, so I want to use this example as an introduction to the topic of proofs. Okay? Okay. So if you were doing this question in the test, right, you might have gotten that the largest digit sum possible was 36, right? You get that? Okay. Which you could be certain of based on some reasoning, like as follows. Yeah, so the sum is either a 5-digit number starting with 1 or a 4-digit number, right? Yeah. Therefore, if we can rule out 37 as a digit sum and provide an example of 36 as a digit sum, then we know it is the largest, right? Yep. So, the only way to get 37 is 19999, right? But this means that one of the summands exceeds 9999, right?
Yeah.
Okay. Now take I don't know, you could do any two numbers basically. So like one, you could take like 1, 2, 3, 4, yeah, plus like what are the other numbers? 5, 6, 7, 8. Yeah, 5, 6, 7, 8. Yeah. Oh, oops. No, we can't do that. We need 8765, yeah. Okay. Which is equal to 9999, yeah. Giving us some of 36. Okay, cool, yeah. I think most people could pretty much realize that and be very sure of that, yeah. However, from many of the students I asked, it wasn't so clear what the minimum possible digit sum was, yeah. Though many believed it was 9, yeah. Do you think it was 9?
Yeah, I got 9.
Or 9. So your answer was 27, yeah. Yeah. So that's a different. Like I say, if I say the correct answer is 27, right? You'll be happy about it, right? Because you got it right. Yeah. But the fact that you weren't sure you were right before I told you meant you needed like some luck for it to be right. Does that make sense? So the actual value of your answer is like whatever your certainty is times the point value, right? If you're 50% sure, it's 50% times 6 points. It's worth 3 points. Yeah, or 7 points, 3.5 points, right? So, but you'll get 7 points because you're right. Yeah, it's kind of like if you're shooting a basketball, right? The ball could go in and you'll get 3 points, but your shot isn't worth 3 points. Okay.
Yeah.
Okay, so many believed it was 9, though not many were sure of this. Yeah. Even after saying the following reasons, you could see that people were trying to believe more than they were actually satisfied or certain.
I am very certain of my answer.
Really? I'm very certain. You say really, and he just like crumbles like a deck of cards.
Yeah, I say yes. Yeah.
It's like
I'm not crumbled.
I'm really sure. Are you really?
Are you sure about that?
Yeah.
I'm sure. Are you sure about that? Are you sure?
Oh my god, it's a failed basketball shot.
It's not a basketball shot.
Are you sure about
Whatever you do.
that? Crash the Jew? Crash the Jew?
Ow.
Okay, so you could I have the following reasoning, yeah? So follows. Okay. So the 8 digits, the 8 digits add up to 36. Do you know that? Yes?
Yeah.
Okay. And every time there is a carry, you know what I mean by carry over digit.
Yeah.
The digit sum decreases from 36 by 9. Does that make sense? Huh?
Yes.
Yes, sir.
Ah.
So
Yes, sir.
So the least possible corresponds to the most carries, yeah? Which can't be 4, which can only be 3. So therefore, if you have an example of a digit sum 9, then that must be the minimum. Yeah? You see that?
Yes. I have proof So now I'm sure.
Wait, you
Okay.
okay.
See, I think even if you hear this, you're not completely sure, are you? Jasper's not completely sure. See, he's not even sure where we are right now. It's about the certainty. Okay, we're talking about proofs today. Okay, so I mean, maybe I can propose another proof, and this proof is particularly relevant to this class. Okay, because Ronnie typed this up. Okay, so let me give you an example of a proof that I might write. Okay, so here we go. So my claim is this. Okay, so I make a claim. Okay, the claim is the digit sum is always a multiple of 9. Yeah? That makes sense?
No way.
So this actually makes the answer very, very simple now, right? It can only either be 27, 18, or 9. There's only 3 possibilities now. Okay, and that's kind of the missing part of what you were having in the certainty. Okay, and then I'll prove this, okay? I'll prove this claim, okay? So watch as I prove this claim. Okay, so let us consider the digit sum. So let the digits be A, B, C, D, E, F, G, H, yeah? And consider and its digit sum and consider the digit sum D of, so we have notation for this actually, A, B, C, D plus E, F, G, H. Okay, this notation is not meant to confuse you, but we have used this notation in this class. Okay, let's see what this looks like. No. Where is it? No. Jasper. So disappointing.
Oh, I'm full. I ate 3 Nutri-Grain
You know how some people like they don't want certain people to feel negative emotions because it's bad for them, right? And if you make them feel negative emotions, you're like a bad person. You're making me feel a lot of negative emotions right now, okay? I need to be protected from these negative emotions, okay? I cannot handle these feelings. Emotional damage. Exactly. I need to have emotional repair.
That seems you've already had emotional damage. What is
But you can see, like, in this life, you don't really have to be, like, super talented to, like, make money, right? Like, that guy, all he says is something in any Asian person can make that accent. He just, huh? Oh, you know the most ridiculous thing is if a white person speaks like Chinese, they're like automatically famous. Have you noticed this? It's like so impressive when a white guy speaks Chinese. It's like
Like when a Chinese
it's like when I speak English, it makes no difference.
My mom's always like, bro, this Asian, this white guy can speak Chinese better than
What?
this is something.
Yeah, but then there's like the only white guy.
It was that viral video of a person ordering Chinese at a restaurant, and then they were like,
Okay, bro.
Yeah, I told you.
What do you mean?
Yeah.
What do you mean? What do you mean?
Okay, so can you see? Look what I'm trying to say here. We're just considering this digit sum, yeah. So you add these two 4-digit numbers and you take the digit sum, yeah. And I want to show. So I want to show it's. I want to show it's 0 mod 9. Does that make sense? Yeah. You understand?
yes.
Okay, because if I show it's 0 mod 9, it's divisible by 9, right? Okay, so check out this following calculation, okay? Alright. Okay, so what is this thing equal to, mod 9, okay? So remember, the digit sum mod 9 is actually equal to the number mod 9. Remember that? Ronnie wrote this a few times now.
Oh yeah.
Do you remember that? So the digit sum is actually just equal to the number mod 9, see? You see that? Alright, let's see if this does not even have the align environment. Oh crap.
Let's go, funky square.
What a scam.
Let's go, it's a funky square. Like what?
Oh, it works now. See this? So the digit sum is just equal to the number, which is a sum, right? Mod 9. See that?
Yes.
Okay. But the number mod 9, okay, you could, if you're taking a sum and you mod 9, you can take the mod 9 first and then add them up, right? So it's kind of like this. It's hard to emphasize this thing here, but
But there's so much studies.
you could like do it like this. Does that make sense? So you have the sum of two numbers mod 9. You can take the mod 9 first and then add them up. Yeah? Okay. He's starting to see this guy. I like this guy. Okay, and then how do you find out what each of them are mod 9? Yeah? Each of the mod 9 is equal to digit sum, remember?
Yeah.
Yeah? Do you really, yeah?
What?
It's equal to the digit sum, yeah? Mod 9 plus this digit sum. See? You see that?
Yes. I see it.
What? Oh yeah.
Okay. And obviously that's the same as just taking the digit sum and then adding it up to the digit sum and taking mod 9 at the end, right? Oh, why did I do that? That was not good. That I erased. Yes, I erased some stuff. Okay. Okay, I left out a line. Maybe I should add that back in. D of that mod 9. Okay, and what is the digit sum of something? You just add the digits up, right?
Wow.
Any idiot can do this. You just add AB plus C plus D, right? Remember? And this is equal to 36, remember? And 36 is what?
36.
Is mod 0
Mod 0. When I mod 9 0. Mod 0. Guys,
mod 0?
you didn't root it.
Oh crap.
9 mod 0.
Lovely. I love that text thing.
Oh god, that's a free no! You know, we're mod 9. Oh, no, I never had. Alex can't.
You see?
I see. Very lovely.
Isn't that beautiful?
Sure.
Okay, so like what you consider to be a beautiful proof, it does depend on your context. Okay, if you never learned about mod 9, you'd be like, oh, I like the proof better that was just like carryover thing, right? But if you learn the mod 9 thing, this is like this gives me absolute certainty. With the carrying over, I'm constantly thinking like, do I have it right in my head or not? Okay, even though I'm sure it's right, um, I feel like I'm more sure it's right like this. Okay. All right, what do you guys think?
Cool. Very cool. Oh no, I can't look myself up.
Okay, so there's a lot of things to this proofs chapter that um, we actually did on Saturday, so I'm not going to repeat all of that. I actually repeated this because I think it was particularly cool and relevant to you. But do you get that? Who appreciates this?
Me.
Really?
Yes.
Like this is the kind of thing. Like this is the kind of thing. If I were you and I saw this right now, I would frame it and put it in my room, and admire it every day. But for some reason, you seem to take this for granted.
The frame's not big enough.
Not great.
Yeah. It's perfect for us, right? We learn the mod 9 thing and we use it to prove this. Okay? So, yeah, I mean, and the main difference with AMC and AIMO is this proof writing business. Okay? So, see, AMC, if you get the wrong answer, you just lose all the points, right? But here, if you get the wrong answer, but you have proofs that are nice, you'll still get the points, but not all of them, yeah? Yeah, I guess the thing that makes this proof nice is it gives you certainty, right? You're no longer saying, "Oh, I think it's 27. I'm probably sure it's 27. I'm absolutely sure it's 27." Yeah, because I got something with 9 and 36, and that's the biggest multiple of 9 that can be, right?
Yes. Yeah.
Okay. Okay, so then let's skip to. So proofs involve lots of logic, okay? And the main thing about logic that I want to talk about, what are the implications? No. What happened to the implications? Okay, anyway, so that's that for that. I'm gonna start a new